Good afternoon, all of you. So, today we will start from distribution of earthquake and volcanoes, because last day you know that we have completed up to the ocean floor configuration from page number 32. So, this chapter, distribution of ocean and continent, in this chapter today we will start this part, distribution of earthquake and volcanoes. Chapter name, distribution of continent and ocean. Sorry, distribution of ocean and continent. This chapter. Distribution of earthquake and volcanoes. Study the map showing the distribution of seismic activity and volcano given in the figure 4.2. In your book also have the picture. Next page they are having world map, and also in this map having some dot which also indicate the hotspot, volcanic eruption, shadow of earthquake zone and deep earthquake zone. So, these are the information you will get from this map which have in this page, page number 33. Now, you will notice a line of dot in the central part of Atlantic Ocean, almost parallel to the coastline, almost parallel to the coastline, like that. That dot line have in this map, it bifurcates a little south of the Indian subcontinent with one branch moving into the East Africa and the other meeting the similar line from Myanmar to New Guyana. You will notice that the line of dot coincide with the mid-oceanic ridge, the shaded belt showing another area of concentration coincides with the alpine Himalayan system and the rim of Pacific Ocean. In general, the foci of the earthquake in the areas of mid-oceanic ridge are also shallow depth, whereas along the alpine Himalayan belt are as well as rim of the Pacific, the earthquake and deep-seated one. The map of volcanoes also show a similar pattern. The rim of Pacific is also called rim of fire due to the existence of active volcano in this area. Only this topic you will remind this portion. Rim of fire. What is this? Rim of fire. Rim of fire means you have seen in a Pacific Ocean along the coastline of Pacific Ocean, they are having numerous type of volcano is situated like that. And this series of volcanoes simultaneously erupted, volcanic eruption also occurred underwater. And these areas, it is called rim of fire. So, rim of volcanoes which is situated in the Pacific Ocean, this is called rim of fire. Very important due to the existence of active volcano in this area. Due to the existence of active volcano in this area. This is the active volcano. So, this is called rim of fire. So, rim of fire found in which ocean? It is also MCQ question, you know that. Pacific Ocean. So, rim of fire are located in Pacific Ocean. So, only from this paragraph you will just read about this. Under the ocean, they are having some area in mid-oceanic ridge. What is mid-oceanic ridge? Last day I have discussed, when I have discussed about the ocean floor configuration, you have seen that mid-oceanic ridge is also a place in the center part of the ocean, and it is the margin of two sides, and from the mid-oceanic ridge both sides have similar or equal type of rock structure can be identified. So, distribution of earthquake and volcanoes under the ocean water from the map you can understood, and in this map is also very important for map pointing. You will mark it in your book. This map is very important for map pointing also. Okay, page number 33. Their world map 4.2 figure. This is the important. Now, concept of seafloor spreading. Now, today we will discuss another topic. So, first I have already discussed about one theory. This is continental drift theory. You have read that. Continental drift theory. Continental drift theory you have read, and now another one is concept of seafloor spreading. This theory, concept of seafloor spreading, also related with the ocean floor configuration. Also you can relate it with the ocean floor configuration, and this seafloor spreading also related with continental drift theory. That is why in the same topic you have read about continental drift theory as well as this portion. Now, as mentioned above, the post-drift studies provide considerable information that was not available at the Wagner's time at the time Wagner put forth his concept of continental drift. So, as I mentioned above, some post-drift theory. Some post-drift theory is also very important, and this post-drift theory also provide considerable information, and that was not available at the time of Wagner put forth his concept of continental drift. Particularly, the mapping of ocean floor and paleomagnetic studies of rock from oceanic region revealed the following studies. So, it is also very important. So, the mapping of ocean floor and paleomagnetic studies of the rock from the oceanic region revealed the following fact. So, ocean floor and paleomagnetic study both help us to understood the seafloor spreading. So, seafloor spreading means ocean floor spreading, then means ocean floor shifted from their actual position to different direction. In this theory, we will discuss with some evidence. So, there are following facts. It was realized that all along the mid-oceanic ridge, volcanic eruptions are common, and they are bring huge amount of lava to the surface in this area. So, concept of seafloor spreading, the first thing, concept of seafloor spreading, there we have seen that the floor shifted, and from mid-oceanic ridge, the center part, mid-oceanic ridge, in the mid-oceanic ridge, it is very common that lava also flowing, and their lava also deposited due to the lava flow from the mid-oceanic ridge, because they are having volcano. and these areas lava also deposited. From mid-oceanic ridge, lava also erupted and lava also deposited. Now, next part, the rock equidistance on the side, either side of the crest of mid-oceanic ridge show remarkable similarity in terms of period of formation, chemical composition and magnetic properties. From mid-oceanic ridge, both side, these two parts, they are having lots of similarities of their formation, similarities of their chemical composition, similarities of the magnetic properties. So this is also help us to understood that from mid-oceanic ridge, the ocean floor also shifted or spread in different direction. Rocks closer to the mid-oceanic ridge have normal polarity and are the youngest, and the age of rock increase as one move away from the crest. So this rock and that part, among these 1, 2, 3, 4, these two rocks age older than this one because it is far away from the crest. This rock far away from the mid-oceanic ridge. That's why from the crest of mid-oceanic ridge, when the distance increases, the rock's age also increases. Near the mid-oceanic ridge, the rock's age is younger, and those rocks situated far away from the mid-oceanic ridge, both sides, their age also older. So this is also important. The ocean crust rocks are much younger than the continental rocks. The ocean crust rocks are much younger than the continental rocks. Understood? The age of rock of the oceanic crust is now where more than 200 million of years old. Some continental rock formation 3200 million years ago. The oceanic crust, their age 200 million, but continental crust million. So you understood this. The sediment on the ocean floor are unexpectedly very thin. The sediment of the ocean floor, the sediment which are deposited here, these sediment of the ocean floor are unexpectedly very thin. Scientists were expecting, if the ocean floor were as old as continent, to have complete sequence of the sediment for a period of much longer duration. However, now where was the sediment column found to be older than 200 million years ago. You only remind this part. The sediment is very thin in the ocean floor, which is also help us to understand that ocean floor is much younger than continent. Ocean floor is much younger than continent, and the mid-oceanic ridge, it is the most youngest part of the earth, because here volcanic eruption also occurred, and these volcanoes deposited beside their area. So according to the age, according to the position of the rocks, we can understood their age, and also we can understood their different similarities. The deep trenches have deep-seated earthquake occurrence, while the mid-oceanic ridge are areas the earthquake foci have shallow depth. So deep oceanic trench have deep-seated earthquake occurrence, but mid-oceanic ridge, the earthquake also occurs simultaneously, because this is the youngest part. So suppose this is the mid-oceanic ridge. This is the mid-oceanic ridge. Beside that area, from mid-oceanic ridge both side. Can you see the board proper total portion you can see? Yes. So from this picture you can understood from mid-oceanic ridge, this is A, this is B, this is C. So among them three part, which one is much older? Now you will tell me. A, B, C, which rocks is much older? C. Rest of them? A, B, C. So someone have told C is the oldest and youngest is A. Yes, because so that means you can understood this. Those rocks nearer to the mid-oceanic ridge, their age is quite young. That's why these are young and these are old. Okay, and also have their similarity, which this is also help us to understood that this rock also once upon a time situated here and which is shifted toward that side. That means this is seafloor spreading. That means this is seafloor spreading. Understood? This is seafloor spreading. So this 5 point is very important. If this question, long question will come, they explain the seafloor spreading. So on that time you have to mention these 5 points. Okay. So each and every point you have to understood properly. So this fact and the detailed analysis of magnetic properties of the rock on either side of the mid-oceanic ridge lead Hess to propose his hypothesis known as seafloor spreading. So scientist Hess in 1960 first introduced his theory. This is 1961. 1961 introduced this theory, which is named is seafloor spreading. Hess argued the constant eruption at the crest of the oceanic ridge caused the rupture of the oceanic crust and the new lava wedged into it, pushing the oceanic crust on either side. The ocean floor does spread the younger age of the oceanic crust, as well as the fact that the spreading of the ocean does not cause the shrinking of the other made his think about the consumption of the oceanic crust. He further maintained the ocean floor that gets pushed in due to the volcanic eruption at the crest, sink down the oceanic trench and get consumed. So, this is also up to this is the seafloor spreading theory. So, first when you will write about the seafloor spreading theory, you have to mention about the introduction of this theory. The scientist Harry Hess first introduced this theory, and then after that the remaining portion, that means the 5 point you have to explain, and if you can draw this diagram also like that. Okay. Okay, student. So, after this you will read. Next day we will start another topic. Okay.